Hello, good evening, everybody. Today, I will be discussing the logarithmic functions and exponential function. Right? The log function. Before I discuss the log functions, if is there any natural number? Suppose we have 8. Now, 8 we can write in two ways. 2 to the power 3 is equal to 8. Right? 2 to the power 3 is equal to 8, or we can write log of 8 to the base 2 is equal to 3. This is called writing any natural number or any positive real number. Any positive real number in the exponential form, and this is called logarithmic form. Actually, both of them are the same thing. Both of them are the same thing. 2 to the power 3 is equal to 8 is equal to, we write log of 8 to the base 2 is equal to 3. You know that this 2 is called what? Base. This 3 is called what? Power, indices, or the exponent, and this is equal to 8. Now this 8 here, here 8 and base is 2. 2 base is also here 2. Log of 8 to the base 2. When we write here, then we think that yes, log of any number when we are writing, according to the base, what should be the base? Base can be any number. Base can be any number. And in detail, I'll talk that when the base is 10 or the base is e, then it is called something different. That's common logarithm and natural logarithm. That I'll talk later on. But right now, it can be any base. Right? That means, now if I give you another example for any number, suppose if I write here 3 to the power 4 or 3 to the power 3 is equal to 27, right? That is, now write here log of 27 to the base 3 is equal to 3. When I write here log of 27, right, find the log of 27, base should be base here 3, and that value is how much? 3. That means here I can read that if the base is 3, that means 3 written how many times or multiply by how many times, so that it should give you 27. That now 3 multiplied by 3 times gives you 27. That's why it gives you 3. Now in generalize, if I write a to the power x is equal to y. A to the power x is equal to y. It means what? Log of y to the base a is equal to x. Log of y to the base a is equal to x. This is what? Exponential form. This is what? Logarithmic form. When we talk about this 8, already discussed that it should be a positive real number. That means if I write here log of y, that means y should be greater than 0. Right? Very, very important thing. Second thing, this base a also should be greater than 0 and a should not be equal to 1. Why this a is not equal to 1? Right now I am not talking about. Just I am saying that the value of a should be greater than 0. That means the base should be greater than 0. And the number of which we are going to find out the log, that should be also a positive number. That should be also greater than 0. Right? Let us see some more example. If I write 5 to the power 1 is equal to 5, right? Exponential form, can I write log of 5 to the base 5 is equal to 1, right? Now, if I write here 10 to the power 1 is also 10, it implies that what? Log of 10 to to the base 10 is equal to 1. Right? If I write 6 to the power 1 is equal to 6, it implies that log of 6 to the base 6 is equal to 1. Right? And if I write now 5 to the power 0 is equal to 1, then it will give you what? Log of 1 to the base 5 equal to 0. Now, if I write here 10 to the power 0 is equal to 1, that means log of 1 to the base 10 equal to 0. Now, if I write 1 to the power 0 is equal to 1, then what I will get now? Log of 1 to the base 1 is equal to 0. Log of 1 to the base 1 equal to 0. And see here, right hand side, 1 to the power 1 is also 1. It means that what? Log of 1 to the base is also 1. Now see, two things I am getting here. Log of 1 to the base 1 equal to 0. And log of 1 to the base 1 is equal to 1. That's why the condition which I have written, that the base log of any function is defined only when the base is not equal to 1. Because out of these two, any one should be correct. That means we define that it is only correct when the base is not 1. That's why the base of the logarithmic functions should not be equal to 1. Right? Got my point? Now let us see. If I write b to the power x is equal to y in the exponential form, what will be the logarithmic form? Log of y to the base b is equal to x. Here y should be greater than 0, b should be greater than 0, and b should not be equal to 1. These are the three conditions which we have to remember. That is the log of any positive real number we can find out, first thing. Second thing, base should not be equal to 1, right? And it should be greater than 0, right? Because when I say simply b greater than 0, all positive, then we can have 1 also. But just as I have shown you the example, then we have the complications. That's why the log is defined only when the base is not equal to 1. By the way, log of, if I write here, log of x to the base x is equal to 1, provided x is not equal to 1. Because just I have given you the example that 10 to the power 1 is equal to 10, 5 to the power 1 is equal to 5, 6 to the power 1 is equal to 6. That means if I write this all number, all these numbers are in the exponential form. If I write in the logarithmic form, what will I get? Log of 10 to the base 10 is equal to 1. Log of 5 to the 5 is equal to 1. Log of 6 to the base 6 is equal to 1. Right? And log of 1 to the base 1 is also equal to 1. But that is not defined. Therefore, if any number we are finding their log and the base is same, then its value will be always 1. Very, very important. That means I can write now the log of x to the base x is equal to 1. Right? Where x is not equal to 1. Except that for any value of x it is true. That means suppose I have to find out what the value of log of root 2 having base root 2, answer will be 1. If I ask log of 8 having base 8, answer will be 1. Because see, the log of which number we are trying to find out and the base both are same, then the answer is 1. One more thing, that if you are trying to find out 10 to the power 0 is equal to 1, so now I will say that log of 1 to the base 10 is equal to 0. And this is true for any number, because you know that any number raised to the power 0 is equal to 1 provided it is not 0 itself. This is not correct. Except 0. Except 0, if I write any number raised to the power 0, any number raised to the power 0 is equal to 1. Any number raised to the power 0 is equal to 1 provided that any number is not equal to 0. This system is the correct, right? Therefore, if I write here 5 to the power 0 is equal to 1, 6 to the power 0 is equal to 1, 9 to the power 0, minus 9 to the power 0 is equal to 1. That is what I can say now. Log of 1 to the base 5 equal to 0. Log of 1 to the base 6 equal to 0. Log of 1 to the base minus 9 equal to 0. But this is not correct. Why? Because here the base is getting what? Negative number. And the base should be always greater than 0. That's why this is not correct. Got my point? Right. Now I'll go for the definition of the exponential function and the logarithmic functions. Right now, in hand to hand, I have discussed the exponential form and the logarithmic form of any given function. Now, as far as the definition is concerned, first I write the definition of exponential function. Exponential function. I think you must have heard about one number e. 1 plus 1 by 1 factorial, 1 by 2 factorial, 1 by 3 factorial, and so on. This is called e. This is called e. The value of e is less than 3 and greater than 2. The value of e lies between 2 and 3. Right? Right? This is the value of e. Please note it down somewhere in your notebook. Right. Now, the exponential form. The exponential function with positive base. The exponential function with positive base be greater than 1. Positive base greater than is the function defined as power to be there, that is y is equal to f of x is equal to b to the power x. Y is equal to f of x. Whether you should write this f of x or not doesn't matter, but since it is a function in x, that's why I can write y is equal to f of x is equal to b to the power x. Simply that is, remember, y is equal to b to the power x, where b is the base. The y is equal to b to the power x. Right? And this is the exponential form. But when I replace this b by e, that is y is equal to e to the power x. But y is equal to e to the power x. Here b is any number. I have taken about b, positive real number. B any number. Out of that b I have taken here what? E. And right now I have discussed that the value of e is what? Between 2 and 3. So now when y is equal to e to the power x, then it is called natural exponential function. Natural exponential function. Y is equal to e to the power x. And y is equal to b to the power bx is any exponential function. Out of that, I have taken one that if this is a particular function y is equal to e to the power x, this is called natural exponential function. Right? Now, you know that if you draw the graph of y is equal to e to the power x, or y is equal to 10 to the power x, or y is equal to 2 to the power x, or y is equal to 4 to the power x, any number if I take, then let us see how the graph of this function is there. Right? You have the function y is equal to, if I take two numbers, y is equal to 10 to the power x, which I have taken from y is equal to b to the power x, and y is equal to e to the power x. Okay, now tell me, if I take x is equal to 0, if x is equal to 0, the 10 to the power 0 is equal to 1, e to the power 0 is also 1, that is y is equal to 1. That means when x is 0, y is 1. It means what? There is 1 point 0 comma 1, 0 comma 1. Certainly the graph of y is equal to b to the power x. If I draw the graph of any function like this, certainly it will contain 1.0 comma 1, no doubt, right? And if I write here 10 to the power x is equal to 1, so now when x is 1, when x is 0, y is 1. When x is 1, y will be 10. Y will be 10. When x is 2, y will be 100. X is 3, y will be, that means it will go very stiff up. Similarly, when I take 10 to the power minus 1, x is taken now negative, then it comes very near to the x-axis like this. It won't touch the x-axis. Now see the graph. This graph is called what? Increasing function. And this is the graph of y is equal to 10 to the power x. Of course, the y is equal to, this will be the graph of y is equal to e to the power x. Right? Now write something, some point. See now the graph of y is equal to b to the power x or y is equal to e to the power x. This graph is an increasing function, and certainly this graph is going to intersect the y-axis at 1.0 comma 1. Right? Now you can note down something. The domain of this function will be what? What will be the domain? Domain can be any real number. I can take any value of x. Any real number r. What will be the range? That is the value of y. Value of y will be always positive. Positive real number. Positive real number, which I can write r plus. Right? And there will be point 0 comma 1. Point 0 comma 1, which is on y-axis, is always on the graph. Is always on the graph of any exponential functions. Fourth thing, it is an increasing function. It is an increasing function. See the graph of the graph, it goes up, and it is a continuous function. Right? This point is clear. Now I will talk about the definition and the graph of logarithmic functions. Should I go for it? Yes, boys, are you ready for it? Yes. Come on. Logarithmic function. Right? For a is not equal to a greater than 0, a is not equal to 1. Two things. A is greater than 1 and a is not equal to 0. A is not equal to a greater than 0 and a is not equal to 1. Right? The log of y to the base e. The log of y to the base a is, the log of y to the base a is Suppose x, I can take any value. The log of y to the base a is x, where a is not equal to 0 and a is greater than 1. Right. Now for a is not equal to 0 and a greater than 1, the log of y to the base a is x. If a to the power x is equal to y, a to the power x is equal to y is what? A to the power x is equal to y is what? It is an exponential function. And the logistic function we write log of y to the base a is equal to x, where this a, that means this base, should not be equal to 0 and it should be greater than 1. Right? A is not equal to 0 and a should be greater than 1 for any value. Right? Now, log of y to the base a is equal to x. In the exponential form, we write what? A to the power x is equal to y. Yeah, you need many examples for this. Now, if you draw the graph of this logarithmic function, then see the graph. X dash, y and y dash. X is equal to log of y to the base a. See, the log of y is defined only for the positive real number, right? Here we know the condition for a, that should not be equal to 0 and should be greater than 1. Now if I take y is equal to 1, if I take y is equal to 1, that means, or if I take x is equal to 0, then log y will also become 0. That means what? There will be one point 1, 0. There will be one point 1, 0. That means when x is 1, the log of 0 to the base a, log of 0 to the base a, whatever the value it is, it will become 0 only. That means certainly it will pass through the one point 1, 0. If you remember, when I was discussing the exponential form, that was one point on y-axis that was common 0, 1. Here this one point is common what? It is 1, 0. This point will be common for all, right? And it will go, never it will touch the y-axis. See, like this. Now this is the graph of y or x is equal to log of y to the base a. Log of y to the base a. If the base is base a, I have taken here base as a. If the base a is 10, remember this point. If base a is equal to 10, base a is equal to 10, then this logarithmic function is called common logarithm. It is called common logarithm, right? When the base a is equal to e, base a is equal to e, exponential function e, then it is called natural logarithms. Natural logarithms. Generally, the natural logarithms we denote by ln also. Simply, instead of writing log, we simply write ln also. Whenever you see ln, it means it is natural logarithms. In the natural logarithm, base a is equal to e, right? And the common logarithms, base a is equal to 10. We can have any base for the log, right? Now, some properties of this log function we will discuss. First, what will be the domain? Now see, now the domain of log function will be what? Any positive real number. Why? Any positive real number. Positive real number. What will be the range? Range, it can be any real number. Range can be any real number. We can say R. Right? Third, there will be one point. Which one? 1, comma 0 will be common for any graph of log function. Fourth, it is again what? Increasing function. It is an increasing function. It is an increasing function. Got it? 4 points I just asked you to note it down, that the domain of the log functions will be the positive real number, the range will be R, any real number. There will be one point common, 1, comma 0 for any log functions, and it is an increasing functions. Right? This much you should remember while we are drawing the graph of this. Now see one more thing. Guess what I am drawing? Any guess? This is what? X is equal to log of y to the base a, or y is equal to log x, we can write it. That means this is a graph of log functions. This is the graph of exponential function. This is the graph for line y is equal to x. Actually, it is a mirror image. That's why we say that the logarithmic functions and exponential functions are inverse of each other. They are reciprocal to each other. Right? This is y is equal to e to the power x. This is x is equal to log y to the base a. That means this is the graph of in the first quadrant and in the fourth quadrant. But it will not intersect. It will not intersect the y-axis. Right? This is the graph of log functions. This is the graph of exponential functions. Again, the exponential functions are increasing functions which are there in the first and second quadrant. Again, it is not going to touch anywhere this negative part of x-axis. Right? Now, one more thing. X is equal to e to the power log x. Can we write? X is equal to e to the power log x. If yes, how? Okay, let y is equal to e to the power log x. Let y is equal to e to the power log x. If I apply log both the sides, what I'll get? Log of y is equal to log of e to the power log x. It gives you log y is equal to log of log x into log e. Since I have not written the base anywhere, it means it is natural. logarithm I am just writing. That means the base is e everywhere. Base is e, base is e, base is e. Now, when the base log of e to the base e, answer will be how much? 1. It means what? Log of y is equal to log of x into 1. That means log of y is equal to log of x. It implies that when I have started, I have taken the log both the sides. Now I am removing log both the sides. Now log of y is equal to log of x. Therefore, y is equal to x. Provided y should be greater than 0. Why? I am taking here log of y, and we know that we cannot find out the log of any positive or any negative number. That's why the y should be greater than 0. That's the condition. So now y is equal to x, and y I have taken what? E to the power log x. That means yes, x is equal to e to the power log x is true when x is greater than 0. It is true for any value. Suppose I have sin x, right? I can write sin x is equal to e to the power log of sin x. If we have x square, I can write yes, e to the power log x square. This formula will help you at many places when you have to differentiate and when you have to find the integration. That's why please remember it. That means any number we can write like this, right? If we have x cube, we can write e to the power log x cube, right? Now I'll discuss some of the properties of log function, right? Now I'll just prove one or two property and then I'll write all that. Right, the first one is, suppose properties of logarithmic function. Right, first of all, log of a to the base b into log of b to the base a is equal to 1, or it can be written as log of a to the base b is equal to 1 upon log of b to the base a. Do you agree or not? Let us see. Just I'll show you how you can do it and how you can find out the proof of this one. Let log of a to the base b is equal to x. It implies that what? B to the power x is equal to a, right? And let log of b to the base a is equal to y. It implies that what? A to the power y is equal to b. B to the power x is equal to a and a to the power y is equal to b. Now tell me, a to the power y is equal to b and b is equal to, it gives you b is equal to a to the power 1 by x. Can I write or not? B to the power x is equal to a and therefore b is equal to a to the power 1 by x. So now b is equal to a to the power 1 by x. A to the power y is equal to a to the power 1 by x. It gives you y is equal to 1 by x, or it gives you x is equal to 1 by y. Now put the value. X into y is equal to 1. X into y is equal to 1, or x is equal to 1 by y, or y is equal to 1 by x. That means what we have to remember, if you are written there log of a to the base b, and if you want to change the base and base of that logarithmic function, then you can write 1 upon log of b to the power base a. Please remember it. This was the first property. Now the second property, we will go for it. Log of a to the base b is equal to log of a to the base c upon log of b to the base c. See what I have written. Log of a to the base b is equal to log of a to the base c upon log of b to the base c. This c is of my choice. I can take any number over here. and also you can take any number, but this c and this should be same. This cannot be changed. That you will remember. Let us see now. This I'll show you. Let log of a to the power b is equal to x. It implies that what? B to the power x is equal to a, and log of a to the base c is equal to y. It implies that c to the power y is equal to a, and log of b to the base c is equal to z. It implies that c to the power z is equal to b. Right? Now c to the power z is equal to b. C to the power y is equal to a, and b to the power x is equal to a. Now this can I write c to the power z is equal to b, and b is equal to a to the power 1 by x. B is equal to a to the power 1 by x. Can I write? Therefore now b is equal to a to the power 1 by x, and a is equal to what? C to the power 1 by y. A is equal to c to the power y. Therefore can I write now, in place of a can I write c to the power y into 1 by x, that is c to the power y upon x. C to the power z is equal to c to the power y by x. It means what? By equating the exponential, what I am getting now? Z is equal to y by x. Z is equal to y by x. Or I can write x is equal to y by z. Now see the value. This was x, this was x, this was y, this was z. Therefore x is equal to y by z, and hence it is proved. That's why log of a to the base b, I can write not only this, I can write log of a to the base e upon log of b to the base e. Not only this much, I can write log of a to the base z upon log of b to the base z. That is, suppose sometimes we have written log of 7 to the base x. I can write log of 7 upon log of x. Here base is same. Natural logarithm I have taken now. That's why log of 7 to the base x, I can write log of 7 to the base e upon log of x to the base e. Right? Now, in this way, I have discussed the second properties of logarithms. You have to remember this part is very, very important. Whether you know the proof of this or not, that doesn't matter, but the property you should remember. Now, the third one. Now, I won't do the proof, just I am writing the properties. Log of m into n. Base I am taking, suppose I am taking a. Or simply I will go for the next one, e. If this is equal to log of m to the base e plus log of n to the base e. And if there is not only two functions are there, m and p is there, suppose there are three functions m and p, and that is equal to log of p to the base e. For example, what I have written now, log of sin x into cos x base e, I can write log of sin x to the base e plus log of cos x to the base e. That is, if there is a product, we can write as a sum. Clear? This is the third property. Now the fourth one. Log of m upon n to the base e. Again I am talking that base e, it can be anything, right? Log of m by n to the base e, we can write log of m to the base e divided by log of n to the base e. Sorry, excuse me. Log of m minus log n. Log of m by n to the base e is equal to log of m minus log of n. Log of n. That is, when there is a product, it becomes as a sum. When there is a division, isn't it? Then it becomes a difference. By the way, we cannot apply this log functions on addition and multiplication. If there is a log sin x plus cos x, we don't have any formula, right? And the last one, the fifth property, log of m to the base m, having base e or anything, we write n into log of m to the base e, right? For example, if I write here log of sin x to the power 2, then this power is 2, log m to the power n, log sin x to the power 2, I will write 2 into log sin x to the base e, no problem. Log m to the power n becomes n log m to the base e, right? And if there is a division, log of sin x upon cos x, we will write log of sin x minus log of cos x. But remember the same thing, if there is some, we don't have any formula if it is in terms of division and addition, right? We have only these 5 basic rules for logarithmic function, and accordingly we can solve the problems, right? And for any question, and there is one also very peculiar properties of exponential function. The differentiation of e to the power x is simply e to the power x, remain as it is. Therefore, if I have to find a differentiation of e to the power x square, then it will remain e to the power x square into differentiation of what? X square. It will become what? That is now 2x into e to the power x square, right? Differentiation of log x is equal to 1 by x. Differentiation of log x is 1 by x, right? Clear? And differentiation of e to the power x, here e to the power x is e to the power x. But if you have asked to find a differentiation of e to the power x, then what to do? That I will show you what to do. By the way, write the real answer. This is e to the power x into log of a to the base e. Differentiation of e to the power x is equal to e to the power x into log a, right? I will show you how it is coming, this one, e to the power x into log a, right? Y is equal to a to the power x. I have to find the differentiation of this, right? Taking log both the sides. Taking log both sides. What I write? Log of y is equal to log of a to the power x, and log of y is equal to log a to the power x. It becomes what? X log a. Now differentiate with respect to x. So now differentiation of log y, 1 by y, differentiation of y dy by dx is equal to differentiation of x with respect to x will be 1. Log a is a constant term, it will remain as it is, log a. Therefore what? Dy by dx is equal to y into log a, and y is what? A to the power x, a to the power x into log a. That's why the differentiation of a to the power x, differentiation of a to the power x is equal to, we write a to the power x into log a. Please remember this, right? Now you can solve the problems of exercise 5.4, right? Suppose the one question, find the differentiation of y is equal to e to the power sine inverse x. Then what to do? Find the differentiation. dy by dx is equal to e to the power sine inverse x. E to the power sine inverse x will remain as it is. Again, differentiation of what? Sine inverse x. And if you remember, the differential of sine inverse x is what? E to the power sine inverse x into 1 upon under root 1 minus x square. Therefore, we write finally answer e to the power sine inverse x whole divided by under root 1 minus x square. And in this exercise, I think 5.4, there are hardly 10 questions are there, right? And I hope you can do it. And if you have any difficulty, certainly I will discuss. Thank you very much for this today's lesson. And in the next lesson, I will do something more on the differentiation of logarithmic functions. Thank you very much. Have a nice day and enjoy your time. Bye.